Spiky, what are you doing?
I'm playing with the light and the mirror. Look, I can move that patch of light anywhere on the wall.
Do you know why this happens? It happens because of a property of light called reflection of light. Light that bounces back from an object or a mirror is called the reflection of light. The light of the torch falls onto the mirror and bounces back. As a result, we see the reflection of this light on the wall. But here comes a question. Why does that patch of reflected light only appear at a specific place on the wall when we hold the mirror with a certain orientation? Why doesn't the light reflect back to the torch? Here is where the law of reflection of light comes in.
What is the law of reflection?
Let's have a closer look at the law of reflection of light. First, let's learn some important terms related to the reflection of light. Light travels in a straight line. Let's use an arrow to represent a ray of light. The ray of light that falls onto the plane or the surface of the mirror is called the incident ray. In our case, the ray of light coming from the torch is the incident ray. The ray of light that travels away from the mirror is called the reflected ray. Here, the ray that reflects off the surface of the mirror is a reflected ray. Let's draw a dotted line at an angle of 90 degrees from the surface of the mirror. This line is called the normal line or just the normal. It is an imaginary line. The angle that the incident ray makes with the normal line is called the angle of incidence. It is represented by the letter small I and can be measured from the normal line. The angle between the reflected ray and the normal is called the angle of reflection, represented by the letter small r. Like the angle of incidence, it is also measured from the normal. So, according to the law of reflection of light, the angle of incidence is equal to the angle of reflection. If the angle of incidence is 40 degrees, then the angle of reflection will also be 40 degrees. We look into the mirror and see our reflection due to this behavior of light. When we move to the left or to the right side of the mirror, we can see the opposite side of the room. So, we can see a reflection of either the bed or the door. We are also able to see cars behind us by using the side mirrors and rear view mirrors of our cars.
I'm just testing the law of reflection. Hee.
Let's do an exercise. A ray of light falls normally onto the surface of a mirror. What will be the angle of reflection? Take a minute and discuss it. When a ray of light falls normally onto the surface of the mirror, it makes a 0-degree angle with the normal. According to the law of reflection, the angle of reflection is also 0 degrees. Hence, the reflected ray moves back along the normal. This is how we see our reflection in the mirror when we stand in front of it. Time to summarize what we have learned today. The ray of light that falls onto the shiny smooth plane or mirror is called the incident ray. The ray that reflects off the surface is called the reflected ray. The angle that the incident ray creates with the normal is the angle of incidence. The angle between the normal and the reflected ray is the angle of reflection. According to the law of reflection of light, the angle of incidence is equal to the angle of reflection.